In this video, I'm going to cover chapter 3, chapter 3.2, zeros of polynomial functions. So 3.2, oops, zeros of polynomial functions. Okay, so what does that mean, zero? Zeros is nothing but the solution or root. Okay, so specifically, if the function's definition of function is polynomial, so that the type of function is polynomial function, then the x value satisfying the p of x, the function equals 0 is called a zero, a polynomial function. Okay, so so 0 is kind of a special the special case or special name of the the solution of that the polynomial function equals 0. Okay, so here objective is this. By the way, so in 3.2, you can see that zero, the name of the the chapter, zeros of polynomial function. So we're gonna talk about the polynomial function. So why? I mean, so what? F of x is equal to something. So that is polynomial. Okay, it could be a quadratic polynomial or higher degree of polynomial. Okay, so keep in mind this. So now, in this, so this is called the polynomial function. In the polynomial function, is denoted by p of x. So instead of f of x, let me use p of x in this chapter. Okay, so p of x means the polynomial function. Okay, keep in mind this. So objective from here. All right, so first one, we have to learn the remind, I think, because maybe you learned this one in high school. So ordinary division. Okay. And step 2, a second objective is synthetic division. Okay. And step 3, now in the remainder theorems. Okay, and then step 4, then we're going to learn the factor theorems. And then 5, and then we learn fundamental theorem of algebra. Okay, and then I think this is the last one, is the rational zero theorems. Okay, so today I'm gonna cover the ordinary division and synthetic division. Okay, all right. So and then rest of them, these theorems, I'm gonna cover these theorems in next time. Okay, in class. So ordinary division is what? So when I'm talking about this, so think about this. Here goal is this. We want to study how to divide polynomial by polynomial. Okay, so just think about this. I want to divide 7 by maybe 2. Okay, then we know how to do it. It's really easy, right? So 2 times 3 is 6. So we subtract 6 from 7, we got 1. So that is called the what? The quotient, right? And that is called the remainder, right? So let me just use a letter R, capital letter R for the remainder. Okay, so this is the divisor. Okay, this is dividend, right? So now give me a second. C. All right. So now what are you gonna do? We could express the dividend. Okay, it's dividend in terms of the divisor quotient remainder, right? So this is dividend is equal to divisor times quotient. Let me use the letter Q. Okay, Q, and then plus remainder R. You see, it means that 7 is equal to what? 2 times 3 plus 1. We can say that, right? So here, the um, the first goal in this chapter, we want to express the polynomial as express the polynomial in terms of the what divisor and then quotient and remainder, like this. Okay, so then to do that we need to divide the polynomial, right, by divisor. How can you do that? We use this one, ordinary division or synthetic division. So what's the ordinary division? Let me explain this one by solving one example. Okay, so think about this. Let me say p of x, polynomial function. This is example 1 in textbook. Okay, so p of x is defined by 2x cubed and then minus 5x squared and then plus 4x minus 6. So I want to divide this one by x minus 3. Okay, so x minus 3. Then you see 2x cubed. It's just similar to that what we did here. Okay, so minus 5x squared plus 4x minus 6. So what I'm going to do, so we're going to find out the quotient. So first one, we just take a look at the 2x cubed, okay, and then the term having the highest power in the divisor, in this case x, right? X is the term having the highest power. So we'll figure out, we want to try to find out the factor that makes the x to be 2x cubed. So what factor do we need to get 2x cubed from the x? By multiplication, okay? So x times what is equal to 2x cubed, which is 2x squared, right? So x times 2x squared is 2x cubed. So x times 2x squared is 2x cubed. So we just write down 2x cubed here. And then not only just multiply the x by 2x squared, we're gonna multiply minus 3 by 2x cubed, which is negative 6x squared, right? And then we subtract, okay? So that polynomial by that polynomial, okay? From that polynomial. So 2x cubed minus 2x cubed is gone, right? And then negative 5x squared minus 6x squared, which is the x squared. And then we copy down 4x minus 6 plus 4x minus 6. And then now think about this. X times what is x squared? X, right? So we got x squared. X times x is x squared. Negative 3 times x is negative 3x. We just subtract. So we got x squared gone, and then 4x minus negative 3x, which is 7x minus 6. And then plus 7, right? Because x times 7 is 7x. And then negative 3 times 7 is what? 21. And subtract. So we got the 15, right? Okay, now once you get the number, in this case number, right? But once you get the term whose degree is less than degree of the divisor. Here, degree of divisor is 1, right? So, but degree of this guy is 1, that's 0, right? So we just stop. That's gonna be remainder. So this is a remainder. So 2x squared plus 7, x plus 7, that's the quotient. Again, this is divisor. So now we could express p of x as like this, x minus 3 times 2x squared plus x plus 7, and then plus 15. Okay, give me a second. So now, then this is the divisor. Again, let me just divisor. So this is a quotient. Okay, this is a remainder. Okay, okay. So that's the ordinary division. Okay, so let me the introduce synthetic division. Okay, so in the synthetic division, it's not like the ordinary division. We're gonna just write down the coefficient of the polynomial. So in this case, 2, -5, or -6. Okay, so 2, -5, and then 4, and -6. Okay, so I'm gonna divide the p of x by x minus 3 using not ordinary division but synthetic division. Okay, so I just write down the coefficient of the polynomial. But what if, the a polynomial doesn't have a square term? Okay, in that case, you have to put 0. Okay, even even though the square term, or the term whose degree is between two consecutive the power. What I mean is, for example, the value p of x is like this: the 2x to the fourth power, and then plus x plus 1. Then when you start with when you want to divide p of x by, for example, x minus 3 using synthetic division, you have to write down all the coefficient. Even though x cubed, x squared terms are missing, you have to mention the 0 for the x squared and x cubed and x squared. Okay, 0, 0, 1, and 1. So 2 is coefficient x to the fourth power, 0, 0 are coefficients of what? X cubed, x squared terms. 1 is coefficient x, is 1 here. So keep in mind this. Anyway, back to the here. And then now we draw the line like this. Okay, and then here we're gonna write down the number making the divisor to be 0, okay, which is 3. So here divisor is what? X minus 3, right? So 3 makes divisor to be 0, right? So we write down that number 3. And then copy down the first number right here. And then the I'm gonna multiply 3 by 2, okay, which is 6, right? So we write down 6 in the next column, second row, okay, 6, right? And then we divide, give me a second. Excuse me. So, and then we add those to number, okay, in a column, -5 plus 6, okay, which is 1, okay, okay. And then we're gonna multiply 3 by 1, okay. And we write down, which is 3, right? 3 times 1 is 3, right? And then we write down 3 in the next column. We add them up, which is 7, right? Okay. Then we just repeat this process. 3 times 7 is what? 21. We add 2 numbers, we're gonna get what? 15, right? So the last number, that's gonna be remainder. What are they? 2, 1, 7. These are the coefficient of the what? The polynomial whose degree is 1 less than dividend. Okay. So in this case, dividend is what? 2x cubed minus 3 minus 5x squared plus 4x minus 6. So what's the degree of polynomial? 1 less than the degree of the dividend? Quadratic polynomial, right? This is a cubic polynomial. But these are what? coefficient of quadratic polynomial, which is 2x squared plus 1x plus 7. See that? 2, 1, 7. 2 means coefficient x squared, 1 means coefficient x, 7 is what? Means constant term. So q is what? Q is this. It means that quotient is 2x squared plus 7, x plus 7. Okay. Okay, that's the meaning of those numbers. Okay. So therefore you need to practice. Okay. So please look at the example of the textbook. Okay. So I introduced the ordinal division and syntactic division, and then so the reason that we study ordinal division, syntactic division, because we want to express polynomial function in terms of the divisor and then quotient and remainder again. So once we think about this, for a given polynomial function, if we and then we, if you want to express the polynomial function in terms of divisor, quotient, remainder in general, okay. So let's say divisor is x minus c, okay. Then we're gonna get some quotient polynomial saying the quotient function q of x and the plus remainder r, okay. So once we get this one, that expression using ordinal division, syntactic division, then p of c gonna be what? R. Is it? Okay. So actually, that's remainder theorems. If p of x can be expressed as x minus c times q of x plus r, then p of c equals r. Okay, so it makes sense, right? Because if we plug in, replacing x by c, no matter what we get here as q of c, since the c minus c is 0, so we're gonna get r remainder. So that's actually remainder theorem. So I'm gonna talk about this one, okay, all the theorems in the next class. Okay, so let me stop here.